Okay, guys, today what we're going to see is how to solve linear programming problems using Solver. When we use Solver, it is going to be used with the method of simplex, which is a method that is used for solving linear problems. Okay, we have to remember that we're going to be using the simplex method. When we use Solver, we can have more than two variables, which is different from the graphic method because the graphic method, we can only have two variables since we only have two axes. Okay, so we have this problem and it says the company wants to define its production program. That means how much to produce of tables and chairs. Based on the available hours that it has of carpentry and that it has of painting, how much personnel that I have, so it's man hours, to achieve the highest contribution margin. The first restriction is that the carpentry hours cannot exceed 240 hours. That's it. We only have personnel for 240 hours. The time required by carpentry operators to make one table is 4 hours, and to make one chair is 3 hours. The second restriction is for the painting hours. We cannot exceed 100 hours per week because we don't have enough personnel. That's the personnel we have. The time required by painting operators for a table to paint a table is 2 hours, and to paint a chair is 1 hour. And what we're looking is to maximize the profit margin. Okay. So what we're going to take our also is this contribution margin is that the accounting department has told us that we have a contribution margin of $70 or 70 pesos, depending on and where you are, for a table and 50 for a chair. Okay, so that's what we have. And like we saw in class, it is very important that we try to put it in a table form. Okay, to me, the easiest has been to always put the variables on top and to put each restriction in the rows. Okay, so here's a restriction. We have a time restriction for carpentry, which is 4 hours to make a table, 3 hours to make a chair, and we cannot exceed 240. The same, we have 2 hours for painting a table and 1 hour for painting a chair, and we cannot exceed 100 hours. These zeros that I put here, it's because we cannot destroy chairs. Okay, we have a no negativity, so we cannot destroy a chair. Okay, it would be absurd to destroy a chair. And we have a profit margin, which is going to be 70 for a table and 50 for a chair. Okay, so remember we have to find the solution and first find and define certain things. One is going to be our decision variables. So our decision variables are going to be tables and chairs, because this is what Solver is going to be playing with to be able to come up with a maximum or optimization to find the maximum contribution margin. So there's no formulas here because this is where we're going to start, but it's going to be our point where it's going to start playing with it to be able to find the maximum. Okay. Then we have our objective. What is our objective? Well, it is very clear that our objective, in a sense, to maximize the contribution margin of the product. When we want to maximize and we have the product, we don't know how much tables and chairs it's going to be, but we do know how much we can gain from making tables and chairs. So we're going to make our formula. And even though it's going, you can use it, it's always wise to remember that we have to put in parentheses just in case. Okay, so we're going to put 70 times the number of tables that we have plus 50, or the number of chairs, times 50. Okay, so that's what we have, and that's going to be our formula for our objective. That's going to be our mathematical equation. Then we have certain restrictions, and the first restriction is going to be the carpentry. So we're going to go into carpentry, and our restriction is it cannot exceed 240. But what cannot exceed? Okay, the number of tables I am making times the number of hours it takes me to make it, plus the number of chairs that I'm making times the number of hours it takes me to make it. Okay, and it has to be less than or equal to 240. Then we go to painting, and the same thing. we're going to see how many tables it took us times the number of hours it takes us, plus the number of chairs that we're going to make times the number of hours that it takes us to make a chair. That's going to be our restriction because that cannot exceed 100. And that cannot exceed 100. And just to have it clear, we cannot exceed or we cannot destroy chairs. There's no negativity. Okay, that's we cannot destroy a chair. So that now that we have that, we can start with Solver. Where do we find Solver? Well, most of you have already installed it and we installed it in Components. Okay, so we're going to go to our data or to our datos. Okay, menu. And to the very right, literally to the right, it's the last menu. It says Solver. Okay, so once we are in Solver, you're going to see 3 sections. One, and if you can see, it's the same sections that we have right here that I've been asking you to identify. The objective, what do we want to maximize, minimize, our variables, and our restrictions. So our objective, we've already done the formula, and if we do not do the formulas correctly, our Solver is not going to be able to solve it. So we've already done our formula, and it's in that particular cell. We want to maximize, so we leave it there. And what is it going to be changing? What variables are going to be changing? Well, these variables. Okay. And now we come to our restrictions. And our restrictions are going to be, we're going to add, and we're going to say carpentry. Okay. Whatever is in that has to be less than or equal to whatever is in this cell. So this is our formula, and it has to be less than or equal to. Then painting, less than or equal to that 100 hours. And then there are some for common sense. I'm not going to put that each of them that we cannot destroy cells, we cannot destroy tables or chairs. But in this particular case, and we could make half a chair on 1 week and then leave the other half. I mean, we could do that. But we're going to come up with some examples where you really cannot, for example, if you're buying kits, you cannot buy half a kit. You have to buy the whole thing. And then that we'd have to say it has to be a whole number. Okay, in this case, you could, since you're making them and it's your company, you could make half a chair this week and then next week finish off the other half of the chair. So we'll accept, and these are our restrictions. And we're going to come up here, and this is the no negativity. Okay. So we leave it checked. And remember, we said we're going to be working with the simplex method. Okay. Once we have that, all we do is solve. And this is the solution that Solver comes up with: 30 tables and 40 chairs. It's the very same thing that we came up with using the graphic method. Okay. That would be our solution. In the next class, we'll talk about how we can use the sensitivity report to be able to make wiser decisions or even changes.